Hi everyone. So let's go where we left off last time. So let's see the LCM. So we'll understand it more with prime numbers. So let's see what is that all about. So the least 31, the least common multiple, which is LCM of non-zero integers A1 to AK is the smallest integer m such that AI divides m for I from 1 to k and is denoted by A1, A2 up to AK. So let's prove the following. If t is an integer, such that AI divides t for I from 1 to k, prove that A1, A2 up to AK divides t. So by definition, the least common multiple is the smallest integer where all those AIs are factors, or it is the smallest integer where m is a multiple of all of those AIs. So that means that any other multiples of those integers has that least common multiple as a factor. So let's prove it. So you apply the division algorithm to t and the least common integer, the least common multiple. So t is equal to a1, a2 up to ak multiplied by s plus r, where r is in between 0 and this least common multiple. AK. So we have that R is equal to T minus A1, A2 up to AK times S, and since all the AI divides both T and as well as the least common multiple, then it follows that AI divides R. But R is less than the least common multiple, so in particular R must be 0. Because by construction it is the least one where all of the AIs are factors. So that means, and also divides T. So in particular, so AI divides R, so therefore R is equal to 0 because R is less than the least common multiple. And we're done. All right. So let's move to the next question. Okay. So 32. Yeah, actually, let's make this video short. And in the next video, we will be discussing 32 and more importantly, 33. See you guys.